Today's notes on 8.B.4 is about standard, normal distributions, and z-scores. It's the second day on it, so hopefully when you watched yesterday's or 8.B.3 notes, it dealt with still using the z-scores formula that you were introduced to yesterday, which again I'll kind of go over again today, and then also using that standard normal table to help you find what the probability would be. So we're going to start off with this warm-up, which if we were in class we would probably just have you guys work on it for a little bit, and then we would have you explain kind of where the answers came from. But for this first one, we'll go through it together. A survey of a group of women found that the height of the women is normally distributed with a mean height of 64.5 inches. We need the mean for sure. And a standard deviation of 2.5 inches. So those are our two important information there. Now, before, like when we worked on last week with the normal curves, we're not doing that because these numbers, if we were to do 64.5 and 2.5, if you were to fill out your normal curve, the answers here would not necessarily be visible on that normal curve. Instead, we use the z-score formula like you saw on 8.B.3. So we would start with z equals, and you would always start with the mean, with the number that is like your x value or the value you're comparing, so in this case 67, and you would subtract from that the mean, which is 64.5, and then divide it by your standard deviation, which is 2.5. So in case it helps, I'll go ahead and rewrite that again. The z-score formula we used was x minus x bar, which stands for mean, and then over standard deviation, which is that same sigma. So we're going to kind of keep using this throughout today. So once we subtract this and divide, we end up with exactly 1.0. Now here's a hint as you use your calculators to help you with this. If you were to type all of this into a calculator in one time, the calculator does not know to do the subtraction before the division, so think of like order of operations. It will just do it at like dividing these two numbers. Instead, you'll need to use parentheses either along the top if you're going to enter it all in one step, or you could instead figure out what 67 minus 64.5 is first, and then divide that by 2.5. And if you were to subtract these two numbers, you do get 2.5, which divided by itself is 1. Now I added a 1.0 instead of just a 1, and the reason for that is because if you think back to the table when we did that on 8.B.4, tables also have a number first, and then they have a 1 number after the decimal, so either 0.0, 0.1, 0.2, and so on. Okay, so we're going to come back to that in just a second. So we need to find this number, 1.0, in our table. Now if you think back to also 8.B.3, here's another keyword that we saw on 8.B.3 notes, where it said keywords here, less than or equal to, means that you can use the standard normal table as it is with the numbers, because that's how the table has been created for us. So we need to find 1.0 on this table here. So you're going to start off on the left side, find your 1, which is right here, and then looking at the top, 0.0 is that first one. So you want to come down and across until they meet, and it says 0.8413. That's the number we need to take from there. So I'm going to go back up and put in, first I'm going to write it out, just copying it from the table, 0.8413, but if you look at the directions, actually it doesn't say it up here, but we were rounding these as percents, rounded to the nearest hundredths, so we are going to move that decimal point 2 to the right, or you can also multiply this by 100, and you would get 84.13%. So that the probability that a woman is less than or equal to 67 inches tall in this scenario here would be about 84.13%. And that's how we come up with that first one. Now another example, same idea, it still says less than, because that's all we've worked with so far. You will see what happens in a couple of minutes with greater than scenarios, but for the less than you do the same thing, start with your z-score, 63 minus the same mean, 64.5, divided by the same standard deviation, 2.5, and when you type that into the calculator, you get a negative this time, and there was no number in front of the decimal, so we just put a 0, so it's negative 0.6, because again, if you do this on a calculator, you want to either use parentheses along the top or around the top of it and then divide, or you could also instead just do it in 2 steps. Okay, so when you divide the 2, you do get negative 0.6. This we need to find in our table. So again, we go back down to the table. This time you want to find negative 0 on the left here. I know there's a 0, there's a negative 0. You want to start at the negative 0 and go all the way across until you're at 0.6, which is the 0.2743. So again, I'll write that up here. And then we write, 2743. And then we'll write this as a percent, rounded to 2 decimal places. So it would be 27.43%. Okay, so those were just review problems, the first 2. But we want to move on to the next few, which are basically all they're going to do is change less than or equal to greater than or equal to. But they might say it in another way, like we're about to see. At least is another 2 words that you'll see that will mean the same thing as greater than or equal to. And we handle these problems a little bit differently. So let's start off with the first example. It says, finding the probability that a woman is at least 58 inches tall. So again, we know what our x is for our z-score formula. We know our mean. This is the same mean we're using as above. Same mean, same standard deviation. Okay, so we're going to start off with the z-score. So 58 minus 64.5 and divide it by the standard deviation, which is 2.5. Okay, when I figure out this answer, when I again subtract the 2 numbers and then divide by 2.5, I get a negative 2.6. Okay, that's my z-score. So I did part A so far. That's all you would do. Part B says, what does the z-score represent? So since I got negative 2.6, it tells me that if I think of like that x value, 58, it is 2.6 standard deviations away from the mean. Well, instead of just saying away, we're going to say below, because it's a negative. So negative would mean going under the standard, or it's under the mean. So standard deviations below the mean. So then the last part says, okay, now use your table, the standard normal table, to estimate the probability. Now here's what we need to make sure we're clear with. At least does not mean less than or equal to. At least is greater than or equal to. So it's saying actually here that how many of the women are greater than or equal to 58 inches tall. We need to find that percentage. So we will still need to use this table, but we cannot just copy down the answer we end up getting. Here's what it would look like instead. So we're going to go look for negative 2.6 in the table. I'll write down the answer that we get from our table. We'll write it down right here. But then we'll come back and we'll talk about, well, how are we going to actually find that percentage. Okay, so negative 2.6 would be all the way across here. The 0.0047 is what we get from the table. So although if we think about less than or equal to, we would have said 0.47%, because we would move that decimal point 2 to the left. But if we're, this time we're asking about greater than or equal to, so we need to actually think about the normal curve being 100%. That's what the probability under a normal curve is, just like you did last week or the last segment when you drew out those normal curves and we filled them in. So in this case, in order to find the answer, instead of doing percents, because I'm not there yet, this is a decimal, I would just do 1 minus the answer you get from your table. So this is from the table. You're always going to do 1 minus that so that you can find out what the probability is. Now the answer should always be positive because we're dealing with a percentage. It should be a number that's positive. Now in this case, 0.9953 is what we get when we subtract 1 minus that number. And then it still helps to see this as a percentage. So moving the decimal point 2 to the right and getting 99.53%. A little bit more clear looking at how many women were there. Well, it's almost 100%, but not quite. Alright, we'll try a few more examples like this, but you just have to read carefully whether it's saying greater than or less than, or at least or at most, because at most actually means less than or equal to. So in this one, we're going to kind of treat it just like we did on the ones before and from yesterday when you did 8.B.4. So it says find the probability that the woman is 69 inches tall. So here's my z-score formula again, 69 minus 64.5 divided by 2.5, and then grab a calculator. This one comes out to 1.8. Again, that's not your final answer. We're going to come back and figure out, well, what's the actual probability for that once we get to the standard normal table. Again, it says, what does a z-score represent? So this one, it talks about, or it's a positive z-score, so it would be 1.8 standard deviations above the mean. And then we have the last question that deals with the normal table again. We're going to need to find 1.8 in our table. And again, you have to think, do I have to do 1 minus it, or is it just the answer from the table? So 1.8, we're going to have down here, positive 1, then go all the way across to 0.8. And it's 0.9641. So again, this is from our table, and in this case, the answer is just that. It's going to be, we'll write it as a percentage, but we do not subtract 1, we don't do 1 minus this number, because that would be only in the case for greater than or equal to. So my final answer here is 96.41%. That's kind of how we walk through the first page here. Just same idea on the back page. We're going to practice a few more scenarios, but the main idea there is, again, is it greater than or less than? If it is greater than or equal to, those will do the same thing for both. We will always do 1 minus what you get from the table. All right, so as we go to the next page, you'll want to possibly print out one of these table reference sheets that have been posted for you. It'll be helpful as you try out doing these problems. Instead of having to always flip the notes and so on, you can just have another paper handy. So I'll do the same as I get to the back. All right, so it says a normal distribution has a mean of 20 and a standard deviation of 0.25. So again, use that formula from the front page. We have, I'll write it up here again, x minus x bar over standard deviation. And again, remember, x bar is the mean. So we have here a normal distribution as a mean of 20 and a standard deviation of 0.25. So we would substitute in the x, which is the first one we have is a 19.4. So we'll do z equals 19.4 minus our mean, which is 20, and then divide that by the standard deviation, which is 0.25. Definitely use a calculator to help you with some of these, so that because you're dividing some decimals. So this one, again, use a calculator to help you, but it comes out to negative 2.4. And then we're going to find this negative 2.4 in the table. Go ahead and show you a sample table here. Negative 2.4, you're going to start at the negative 2's right here and then go across to 4. And you could again flip to the front page if you wanted to follow along and kind of find it yourself. So this would be 0.0082. So again, that's for my table, 0.0082. And you have to now decide, do I want to do 1 minus it or not? And since this is less than or equal to, I do not want to do 1 minus it. So this would be your answer, but I'm going to go ahead and write it as a percentage. So we're going to move that decimal point 2 to the right, and you get 0.82%. Alright, same idea on the next one, except now it says greater than or equal to. So this is the one where we're going to want to subtract. So let's start with 20.4 minus 20 divided by 0.25. This one gives me 1.6. Once I calculate that. Okay, now we again need to find 1.6 in our table, but keep in mind that that's not going to be our final answer because we have to do 1 minus it. But let's first find it. 1.6. All the way across, and we get 0.9452. So I'll write it here, table 0.9452. And we want to do 1 minus that this time. because it said greater than or equal to. That gives me 0.0548. And then again, we want to write this as a percentage, so it would be 5.48%. Alright, we have one more. The next one looks a little different because there's an inequality that shows kind of in between two numbers. And so the nice thing is, if you look at this inequality, it doesn't have any new numbers. It's using the same 20.4 and 19.4 that we just calculated. And so now it's saying it wants the x values to be between those two numbers, just like you did with normal curves when we would say, well, what's the percentage, what's the probability from going from like this much to this much? Same idea here. So for 19.4 to 20.4, we want to just look at the percentages and then we would subtract them. So if you think back to the tables for each of these, let me just like write a couple of notes here. Negative 2.4 was a z-score for that one. 1.6 was a z-score for 20.4. Then we went to the tables, and I'll write down what we got from each of our tables. It was 0.0082, and this one was 0.9452. And so those are the amounts of the tables. We want to say it's everything between those two amounts. And so to find that difference, we're subtracting 0.9452 from 0.0082. And when you subtract those, we get 0.937. And then you want to write this as a percentage again. So we would get 93.7%. Alright, the last example, example 4, says suppose the yearly rainfall totals for a city in Northern California follow a normal distribution with a mean of 18 inches and a standard deviation of 6 inches. So this is in context. We're doing the same stuff though, it's just now it's in a scenario here. For a randomly selected year, what is the probability that the total rainfall will be in each of the following intervals? So we have greater than, we'll have to do the 1 minus for that. We'll do a between like we just did here. When we subtract the two numbers from the table, another between for letter D, and then a less than, which is just taking a number from the table. So before we do that though, remember always start with the standard normal, or the z-score formula, because we really don't know what we need yet from the table. So we want to do, this is our x, which is 30, subtract the standard, or the mean, which is 18, and then divide it by standard deviation. This comes out to 2, just kind of exactly 2, because this is 12 divided by 6. But again, you'll want to write it as 2.0 to help you find that in the table. So here is the table for 2.0. It's 0.9772. So from the table, 0.9772. That is our number for the table, but it's not it's not your final number, because again you have to subtract 1 from that. 1 minus 0.9772 because it said greater than. So this comes out to, final answer is 0.0228. And that number needs to be written as a percentage. So again, it's 2.28% when you move that decimal point. Alright, we have a few more here, 15 and 21. We need to now find the z-scores for both of those, because that's how we're going to subtract the two numbers from the table. So we'll do z-score for 15 and find that answer. This one comes out to a negative 0.5, but I would probably write it as negative 0.5 because you can find that easily in the table. Same thing for the second z-score, use 21. So this one comes out to a positive 0.5. So we need to find both those numbers in the table, and I'll actually write them right here next to them. So from the table, here were the numbers that we get. So 0.5 and negative 0.5. It's going to be right one top of the other. You want to go to negative 0, go across till you get to 5, and it's 0.3085. And then the one right below it is the one for positive 0.5, which is 0.6915. So I'll write down both of those. 3085 is the first one. The second one was 0.6915. Alright, and then from here we subtract these two so that we can find what's between them. So 0.6915 minus 0.3085 comes out to 0.383. And then we want to write this again as a percentage. So we would say 38.3%. Alright, and then the last few examples we have left, or the last two that go with the same scenario, we're going to do a less than. It says 27 inches. So again, we have to do another z-score formula for this one. So we have z equals 27 minus the same mean, which was 18, divided by 6, which is the standard deviation. This one comes out to 1.5 as a decimal. I know as a fraction it would be 3/2, and you don't want to leave them as fractions. You always want the decimal so we can find it in the table. So let's find this number in the table, and we will not subtract 1 from this because it is a less than example. So 1.5. Here's 1, go all the way across to 0.5, and it's 0.9332. But again, I want to write that as a percentage, so it's 93.32%. And finally, our last scenario for between 24 and 33 inches, you have to do, again, 2 more z-scores, because if these numbers you've never found the z-scores for them in an earlier example here, with these same numbers, you'll have to find them each time. So 24 minus 18, divide that by 6. That answer comes out to exactly 1.0, I'll write it as, so that's easy to find in the table. And then for the second one, 33 minus 18 divided by 6. This one comes out to 2.5. And then we want to find both of these answers in the table, and then we want to subtract the 2 again because it says between. So let's go to our table and find both of those numbers. So we have 1.0, which is the first one across, so 0.8413. And then for 2.5, we have 2 here, all the way across to 0.5 is 0.9938. Alright, and now we are just subtracting those two numbers and getting our final answer. So 0.9938 minus 0.8413, that comes out to 0.1525. And then we want to write this in as a percent again, so 15.25%. Alright, that's the final answer. So definitely try out the homework that goes with this. The answer key is posted for you, and then try out that last, the quizzes for this unit as well.